Hey everyone, just doing a quick video on a couple of problems that you might see in a quiz, or especially some phrasing that you might not know what to do with. So this first one we're going to take a look at says, use the rational roots theorem to factor the following polynomial over the set of rational numbers. Over the set of rational numbers, this factoring, right, when it says that factor over the set of rational numbers, this means when I have my factored form, everything should be either an integer, like a whole number, or a fraction. So no roots, no i's, none of that, only fractions and whole numbers. So what I want to start with is two ways that you could do this, depending on if they give you this hint or not. So they give you a hint, right? One root is this -3 minus 6 root 6 times I. Now, if you are not using a graph, this hint is going to be useful in one way, because you could know that its conjugate is also a 0, right? So if this is a root, -3 plus 6 root 6i is also another root. And then there's two more out there, so you could try to use those to find the other pieces. What I'm going to do is take a little bit different approach with a graph. So we're going to go ahead and graph this here. So I have my Desmos, so I'll pull over, type that in, and then we'll take a look at the graph. All right, so I got this entered into Desmos. We got the y is x to the fourth minus x cubed plus 181x squared plus 1209x minus 3150. And this is going to be very far up and down, right? So if I plug in x as 0, this is negative 3,150. So I'd have to go that far down just to find the y-intercept. We're only interested in the 0, so I'm not going to do that. So this is going to do something probably way down at the bottom here, but these are the two zeros that we're interested in, right? So this -7, 0, go ahead and add that point, and then also this one right here, the 2, 0, right? So those are my 2 points that are right there on that graph. That means I also know the factors, right? So x plus 7 and x minus 2 will also be factors. So I can go ahead and write those in, right? So I'll go ahead and pull this over to the side so I got more room to write. So this is going to be an x plus 7 and an x minus 2. All right, so those are two of my factors that I can get just right off the graph there. What I will do next is some synthetic division, right? So this is one option that you can use when you're trying to find the remaining factor, right? So there's an additional factor here that's going to correspond to the two imaginary roots that I have right here. So let's go and do some synthetic division. So I'm going to put in, let's do the 2 first, then we'll do the -7. So I got the 2, and then I'll copy these coefficients down. 1, -1, 181, 1209, and -3150. Make sure you're very careful to check the exponents, right? If you're missing any exponents, you need a 0 as a placeholder. But I have all of them right next to the fourth, cubed, squared, x, and then constant. So now, right, we'll bring down the 1, multiply and add across the whole thing. So 2 times 1 is 2, add, I get 1. 2 times 1 is 2, add those, I'll get 183. 2 times 183, that's going to be, I'll do that on the calculator real quick, 366. All right, so 366, add those, I get 1575. And then 2 times 1575, that is going to be 3150. Right, and you do want to double check that, right? Don't just take it for granted, and then those should add to 0. If they don't add to 0 at the end, that means either this 2 is not really a 0, or you messed up in your multiplying and adding somewhere. So that is that factor taking out the x minus 2. We'll go ahead and take out the negative 7, that x plus 7 as well, and I can just do this right underneath it. We're not going to take that 0 into account on this step. So bring down the 1. Negative 7 times 1 is negative 7, and I'll go and add negative 6. Negative 7 times negative 6, we get 42, and I'll add those, and that's going to be 225. And then negative 7 times 225, let's go ahead and confirm. That is negative 1575. So negative 1575. Add those, I get 0. So this is the leftover factor, right? So this was started with an x to the 4th, right? On this one, went down to an x cubed. Now I'm down to an x squared. So x squared minus 6x plus 225 would be the leftover piece. X squared minus 6x plus 225. And from that 225, right, or that whole factor there, there are 2 zeros, right? One would be this negative 3 minus 6 root 6 times I. The other would be the negative 3 plus 6 root 6 times I. So that would be the corresponding complex number zeros that go with that factor. But since they asked us to factor just over the set of rational numbers, I'm not going to try to split that up into 2 more factors. I'm just going to leave it like that. So this would be the final answer right there in the box. There is one other way you could approach this, which is to try to take these 2 factors. It's definitely a longer way, but x minus this 0, so x minus the negative 3 would be plus 3, minus the negative 6 would be a plus 6 root 6i, times this x minus, again, minus negative would be a plus 3, and then minus that 6 root 6i. Multiply them out. When you multiply it out, right, assuming I didn't know this ahead of time, you'd have to kind of do a big old FOIL on this guy. But you should end up with this x squared minus 6x plus 225. And then after that, I could do a long division with that on this big old polynomial right here at the beginning. And then factor out what I got left into the x plus 7, x minus 2. That method definitely takes longer. It's a little more involved. But if you're kind of stuck, like if this wasn't a nice factorable thing that I could find the factors of on the graph, that's kind of how you'd have to do it. So like I said, hopefully you'll get some nice factors here. Usually they're not too mean on that, and you do get some nice ones there that you can just pull off the graph. Kind of do it with this synthetic division method rather than going through the other work of multiplying it all out and getting the long division. But anytime you have a complex root, you know there's another one that's a complex conjugate sitting around somewhere. But the graph is also still useful for finding any of your rational zeros. So we'll go ahead and call that good for that problem. And we'll take a look at one more. All right, for this next one, we have these directions. Write a polynomial of least degree with integer coefficients that has the given zeros, 6 and negative 3 plus root 3. Leave your answer in factored form, but make sure there's no irrational or imaginary zeros. So with this one, the key on this one is this term. It's a polynomial with integer coefficients, meaning if I multiply it all the way out, I should only have these regular whole numbers like 3, negative 3, 5, stuff like that, but no fractions, no roots, no i's, any of that. And when it says it has these given zeros, I notice that there's one here with a root. Since our final answer should not have any roots, then I also know negative 3 minus root 3 should also be a root. So that's what I'm going to take into account when I go about this problem. So what we have is right now factored form with all of these guys. We have the x minus 6 we have the x minus this next root, and I'm going to have to distribute that negative. So x minus the negative 3 will be a plus 3. X minus the root 3, so we'll get minus root 3 right there. And x minus, again, minus the negative 3, we'll make that a plus 3. And minus the other negative root 3, we'll make that a plus root 3. So this is our factored form, but unfortunately it has these roots still in it, which is not what they are asking me for. So I don't really have another choice here. I'm going to have to multiply this out just to see what this would be in regular form, right, without the roots. So it's going to be kind of a big old foil. I'm going to try to organize it a little bit. So we're going to say x times the x, right, is x squared. We get the x times the 3, so plus 3x. The x times the root 3, so that's a plus root 3x. And the x is not in the root, right, so we'll kind of leave it over there on the side. So that's taking this x, right, times each of those terms in that second parentheses. Now we'll take the 3, right, go ahead and multiply that one. So the 3 times the x will be a plus 3x. And every time I see a similar term, I'm going to go ahead and line them up vertically. That way I can keep track of these and add them a little bit easier when we get toward the end. So there's the 3 times the x. 3 times the 3, that's going to be a 9. So I'll just put that there. And then the 3 times the root 3, we'll get plus 3 root 3. So I'll go ahead and put that there. All right, last one. We'll go ahead and distribute this negative root 3. So we'll get minus root 3 times x. So we're going to line it up there. We got the minus root 3 times 3. So I'll line this up out here. Root 3. And then the minus root 3 times the root 3 will be a minus 3. So we'll say minus 3 goes right there. And then all of these, right, I want to combine. So I'm just going to do that vertically. So x squared, we'll get here. 3x plus 3x, that's a 6x. And then this plus root 3 minus root 3x, right, those are gone. The plus 3 root 3 minus 3 root 3, those are gone. Both of those add up to 0. And then the 9 minus 3, that's just a plus 6. Right? So this is what I have now, right? Factored form is this x minus 6 times this x squared plus 6x plus 6. These 6's don't really have, in the second parentheses, don't really have anything to do with that first 6. That was just a random number given to me. That's in the first parentheses. But this would be, since it said I could leave it in factored form, this would be factored form without the irrational or imaginary zeros, right? There's no roots, there's no i's. All the coefficients would be integers, there's no fractions. So I could actually call this good. If they didn't want your answer in factored form, I'd have to do one more multiplication that actually multiplies those all the way out. But since they said I can leave it in factored form, this is good enough. So we'll go ahead and leave that there. Anytime you're working through any of these problems, just feel free to use the graph if the graph is useful, right? So this is more like factoring if you have the whole expression out like we did on the first one in this video. Even if there's a hint or not a hint, right, you can still use those zeros you get off the graph right away. And then the second part is if you're trying to construct a polynomial, right, with certain zeros like this one, but you don't want it in that completely factored form with the roots and the i's, then you do have to kind of do this multiplication out for this type of thing. So keep that in mind as well. All right, that'll do it for this one, and we'll see you on the next one.